It'd be great to have that not happen. All right. Oh, there's nothing up there. There we go. All right. So there we go. So we're in 7.4. Remember these big ugly ones? This is why I put this section not on exam 4, because this is a hard section. We've already got enough hard stuff on exam number 4. So how do you do these kind? Do you remember it all? I know you've been studying the other stuff and haven't been really given this thought. Yeah, you let u be that big repeated chunk. See how it's got like y squared minus 5y and then y squared minus 5y again? You let u be that. Remember, this is the ones where we change the letter. We change the letter. So I'm going to let u be y squared minus 5y. And then this equation will become a lot easier because this is just u squared and this is just 8 times u. Remember, you change the letter to make it easier? So it's u squared minus 8u. Excuse me. Excuse me. Minus 84 equals 0. Let me slow down there for a minute. Everybody see that? Everybody see what I'm doing? So these are the kind where we change the letter. And you change it when you see that big repeated chunk, that y squared minus 5y, y squared minus 5y. You let that be u. Okay, and then you solve the problem for u, and when you're done with u, you go back to your original y. Okay, so what do I do with that now? Yeah, I think it, you could do the quad. I think it'll factor. I don't know if that'd be easier for you. When you look at 84, I don't know it off the top of my head either, but you can take your calculator and just divide by 2, 3, 4, what is it? 14 and 6. Okay, if you get all the way down to 6, you get 6 and 14. Yeah, you see 2, if you did 2 and 42. So you got to make the middle, right? They got to add or subtract to make the middle. No way you're going to add or subtract two numbers to make 8, huh? That's not going to work. Not with 2 and 42. If you divide by 3, I don't know, you get crazy stuff. Here you get 21, 3, I don't know what you get, 28? Yeah, anyway, that doesn't work. 4 and 21 doesn't work. 5 doesn't do it at all. 6 and 14. Yeah, 6 and 14. Remember how to do that? You just take that number on the end and you divide by 2, 3, 4, 5, 6 until you find two numbers, 6 and 14, that can make the middle term. Now, how do they make the middle term? Remember the sign in the middle goes on the bigger number, huh? It goes on the minus on the 14. Plus on the 6. Keep that equal 0 there. All right, good so far? Minus 14 plus 6 makes the minus 8 in the middle, and they multiply to be minus 84. Remember, it's multiply to be the back number, add to be the middle. When we do this factoring stuff. Okay, what do we do now? Yeah, so the first one equals 0. Whoops. Cleaned up a little bit. First one equals 0, or the second one. Or you could just go opposite, huh? That's what it always does. If you want to just skip this step. Move it over, negative 6. Move it over, positive 14, right? We good there? So we got minus 6 and 14. But that's the u answer. Remember, the original question had y, not u. So this is all u stuff. Now I have to go back to my original letter, which was y. How do I do that? Yeah, well, you remember what u is. U is y squared minus 5y, huh? U took the place of y squared minus 5y. So when it says u is negative 6, that means y squared minus 5y is negative 6. Remember that? Because u is y squared minus 5y. That's what that top line says. U is the same. So when those two things are equal, that means one can take the place of the other one. Make sense? So u is the same. It's equal to y squared minus 5y. So u equals 14 means y squared minus y is 14. Is that good? Everybody see what I'm doing there? So you go back to y at the end. So after you get your two answers for u, right? Changing to u made the problem easier. That's why we did it. right? The original question looked really hard, and so we said, let's make it easier. Let's just let u be that big repeated chunk, y squared minus 5y. And so that changed it to an easier u equation. We solved that, got our 2u answers, and then we went back and said, okay, yeah, but u all along was really y squared minus 5y. So u is back to y squared minus 5y now. And now we just have to finish up these two equations. So let's start with this one on the left. How do we solve? What do you do when you got a y squared? Get a 0, huh? So jump this over. Get y squared minus 5y plus 6 equals 0. In fact, maybe I'll go to fresh screen here. So we've got y squared, minus 5y. What do we have? Equals negative 6 and equals 14. Yeah, so jump this over, get y squared minus 5y plus 6 is 0, and then we can try to factor that. How does that factor? Minus 2, minus 3, right? Because they'll multiply to be plus 6, two negatives, multiply to be positive 6, and they add to be negative 5, don't they? And so that means the answers are positive 2 and positive 3. Remember, it's just opposite of what's in the parentheses. If you set each one equal to 0, and do all that. And then the other side, bring the 14 over. So y squared minus 5y minus 14 equals 0. So what's that? 7 and 2 multiply to be 14. How can they add to be negative 5? Sign in the middle goes on the bigger. Minus 7 plus 2, right? Minus 7 plus 2 is minus 5 in the middle, multiplies to be negative 14. So then it's plus 7, just opposite again. So the actual final answer is they want all 4. So 2, 3, any order, 2, 3, 7, negative 2. Any order you want to list those with commas. 4 answers. First time we've had 4 answers, I think. We're getting to advanced algebra at this point. Questions on that one? Are we good? Does that make sense how that worked? So that's what we're doing on all these problems. Yeah?
Could any of those be false, like if we were to double check them?
Yeah, no, they're not. You don't need to check them. They're all guaranteed to be good. Yeah. Yeah, today's our test on that, huh? So when I hand you the test, you should look through for any problem that starts with a square root and an equal sign and write check next to it. That's the first thing I would do when I get the exam in my hands. I look through all the exam. Any problem that has a square root with an equal sign. There's a bunch of square roots without equal signs. There's like 2 over root 3, simplify it, no equal sign. Yeah, don't worry about that. But anything with a square root and an equal sign, those are the ones where you must check the answer because the method can bring in faulty answers. This problem had no square root, huh? See how in the beginning there was no square root anywhere? So we don't need to check it. The method is reliable. It's good. On that. Other questions on that one? We good? So, okay. So you see how it's got the same repeated chunk? Since it's got the same thing, it's just repeated. So what are you going to do with that whole repeated chunk?
Make it u.
That's u. So this is u squared. And so, by the way, guys, it's always going to end up being u squared in the front, regular u in the middle. That's what they mean by quadratic form. It's going to end up being a square. Quadratic means x squared, or u squared, or any letter squared. That's what quad means. Why? Why do they call that quad? Because there's 4 parts. See how 1, 2, 3, counting to 0 is a 4th part. Quad, 4. So they call that quadratic form, x squared. That's just fancy language for x squared or u squared or anything squared. So when they say this section is all about quadratic form, they mean the original thing is going to end up looking like x squared. So expect it. You're always going to have u squared, regular u, and you'll do your thing from there. So go ahead and do that. Solve for u, but then when you get u, you got to go back. Let me give you a minute. Got to go back to the original. That's what we always do on these, right? Solve for u, then go back to the original. Let's give that a try. Okay, so what two numbers multiply to be 35 and add to be the minus 2? What times what's 35? 5 times 7. And how do they sign in the middle? It's always on the bigger, huh? Plus 5 minus 7. All good so far? And then you know the answers are always opposites of what's in the parentheses, right? So that would be negative 5 and positive 7. So far, so good. So there's all the U work. Now we need to go back to the X stuff, right? So how do we do that? What is U been equal to all along? That big repeated chunk. U is, right, you took the place of. Do you understand? It's like an actor or something. It's like an actor taking the place of the real person. Right? That's what it is. It's really, you was not the real person. It's the X. It's the X plus 1 over X minus 1. Right? We got to keep straight. Who's the actor? You was just playing the role, standing in the role of the X plus 1 over X minus 1. Right? On there? So when we got U equals negative 5, we go, okay, no. U was just the actor. So when we said U is negative 5, that means X plus 1 over X minus 1 is negative 5. And when U is 7, that means X plus 1 over X minus 1 is 7. Does that make sense? Are we good on that?
Well, can't we just do proportions and then solve it?
So we good to here. Everybody good to there? So that's what. See how the plan with these always follow. You change. You make the thing easier by letting an actor come in and take the role of the messy stuff. You solve the U, but then you go back. Okay, that was really just an actor. Let's go back to the original. U was really taking the place of, standing in for X plus 1 over X minus 1. Now we have to solve this. Now, how do you solve when you got a fraction on one side and a whole number on the other? You put it over 1, cross multiply, huh?
All right.
So 1 times X plus 1 equals, is that a minus 5? Yeah, it's a minus 5, huh? I think I'm going to go to a fresh screen here. This is the end of number 11. Was it so? So yeah, so put these over 1, cross multiply, and solve. Same thing here. And then, then how do you solve when you got x's on opposite sides like that? Yeah, just get rid of one of them. It doesn't really matter which one. So I'll just go plus 5x to both, and that'll just get rid of that one. You could do minus x to both. Just get rid of one of them. It doesn't really matter. Just do the opposite of somebody. This will be 6x plus 1 is 5. Subtract 1. 6x is 4. Divide by 6. 4, 6, reduce it to be 2/3. So 2/3, there's one of the answers. The other one, let's see, subtract x from both sides. Then add 7 to both sides. Divide by 6. So 8, 6, reduce that one, 4/3. So the two answers are 2/3 and 4/3. And we solved it. So are we good with all that? Makes sense how we're doing it? We're using another letter to take the place of the main letter to make it easier to solve. That's the plan. No questions? Is that good? All right. Okay, let's try this one. So, you see the big mess, right? So U is going to replace that big messy fraction there. go ahead and write that equation in terms of u. Solve from there. So 4u squared minus 4u plus 1 equals 0. That's kind of hard to I mean, you could factor it, probably. Yeah, you could factor if you want to. Or you could do the quad, whichever you prefer. You could factor or do the quad on that one. Either one. I never know which way you guys prefer. So you could factor 2u, 2u. Is that good? Does that work for you? minus 1 is actually right. Because, you know, if you FOIL it out, you can see it's right. How about I just say it that way? If you FOILed that out, it's right. Right? If I was to, here would be the check. If you went boom, boom, you'd get 4u squared minus 2u, boom, boom, minus 2u plus 1. See how that would be 4u squared minus 4u plus 1? See how it's right? So that's the right factoring. So that's correct. And so then, so what do you do from there? Well then, each of those equals 0, 2u minus 1, 2u minus 1, right? Because 2u minus 1 times 2u minus 1 equals 0. Two things multiply times to be 0. Either one could be 0. But that's the same equation twice. There's no use in solving it twice. It's going to be the same answer. Move that over. 2u is 1. Divide by 2. Use a half. Going to get the same thing over here. So use a half. A half is the u answer, but now we still got to go back. That's just the actor, right? Now we've got to go back to the original, right? We're going to go back to the original. Now that's just the u answer. Now we got to, yeah, you could have, yeah, you get the same answer by the quad. If you use the quad, you would have got the same thing. Right, if you did that instead. You could have done that. Yeah, do you guys prefer the quad? I know some like one way, some like the other. Yeah, if you did the quad, I'll say or the quad, the negative b plus or minus the square root of b squared minus 4ac all over 2. We call it the quad because it'll solve any quadratic, any x squared, right? So this is a, this is b, this is c. I'll just read. I'm going to get the same answer. I'm going to get a half. Negative b, which is negative 4, plus or minus the square root of b squared minus 4 squared b squared minus 4 times a, which is 4 times c, which is 1, all over 2 times a, which is 2 negatives make plus 4, plus or minus 16 minus 16 over 8. That's 0. That's gone. So you just get 4 over 8, a half. See? Same answer from the quad. You get a half, or if you factor it, you get a half. So a half is the u answer by quad or by factoring. A half is the u answer. Now we've got to use that to get the x answer. How do you do that? Well, remember, u was just the actor taking the place of the mess. So we go, okay, so u is, whatever it is, x plus 5 over x plus 3. Okay, so when they say, so use a half, so when they say use a half, that means this takes the place of u. So that means x plus 5 over x plus 3 is a half. You with me on that? Is that making sense? What I'm doing there? So I solve for u a half, and then u is the big x fraction. So the big x fraction is a half. And then we solve that. So diagonal, diagonal. 2 times x plus 5, 1 times x plus 3. Like that. Distribute. 2x plus 10. X plus 3. Finish solving for x. Subtract x from both sides. X plus 10 is 3. Subtract 10. x is minus 7. And there we go. Is that good? Getting a little better? Think you can do that big mess? Abraham.
What about the 4 and the negative 4? Is it irrelevant? Or
4 and negative 4? Where's that?
the 4 is up front?
Problem.
4.
Oh, yeah, no, those were important. They showed up in the factoring, 2u, 2u,
Oh, okay.
right? Or they showed up in the quad, what I plugged right here.
I'm thinking about like when you plug back in the half. No.
Oh, no, good question, I hear you. Yeah, the u is not, yeah, good question. Abraham's question, good. The u is not the 4, it's just the x stuff. How do I know? Well, because you see right here, the 4 is still there, and then the u. So the u is what comes after the 4. Is that making sense? So the u represented just the x stuff, not the 4s in the front.
The 4's already factored in.
Right? So the u took the place of this. See what I've got circled? That's what the u was taking the place of, not the 4s. Yeah, good. Okay, so so here we go. So we have x to the minus 2 minus 3x to the minus 1 minus 10 equals 0. That's weird looking, isn't it? Negative powers and everything, negative 2, negative 1. What we do is on all the problems in this section, so basically the way you want to think is when you get these weird looking powers and things, you're always going to bring in the actor. We're going to do the u thing again, but it seems a little different because we don't have parentheses and like the same identical repeated chunk, but it's still the same idea. How so? Let me give you the plan. So when you see weird powers, weird powers, like, well, maybe instead of weird, that's not really a technical word. Is it weird? It's weird.
It is weird.
High powers like fourth, things like that, or negative powers, or fraction powers. How about that? That's what I mean by weird. Like fourth powers, or negative powers, or fraction powers. Those are the kind when you're going to do the u thing. What do? You let u equal the middle x power. It's always the middle. U always takes the place of the middle one. You're going to bring in the actor. We say, actor, you're going to play the role of the x stuff in the middle. Not the 3. Let's remember Abraham's good question. Not the negative 3. That's not touched. That's still there. Right? The actor is just going to come in and take the role of the x to the minus 1. That makes sense? The rest of the stuff is still there. And then the front will become u squared. Why? Because it's twice as big. See how minus 2 is twice as big as minus 1? So if u is x to the minus 1, square both sides. U squared will be x to the minus 2, won't it? So u squared is always the front. Is that making sense? The 3 and the 10 are still there. We haven't done anything with the 3. Don't let them throw you out. The 3 and the 10 are still there. Haven't touched them. I'm only changing the x stuff. The other numbers in the front stay put. I'm just saying, hey, the middle's u. The front is twice as big as the middle. Negative 2 is twice, right? Losing $2 is twice as bad as losing $1, right? It's twice as much. So if the middle is just u, then the front's twice as big, u squared. That'll always happen, every one of these. Will become u squared in the front, regular u in the middle. That's why they call it quad form. They'll always become that form. Does that make sense? So the u is the middle, the front is u squared, which is exactly what we did on the big parenthesis ones. And then the rest is what you already know. Solve for u, then replace u, and solve for original. Solve for the original letter. That's what we do. So let's give that a go. So let me solve this u now. Factoring. What multiplies to be 10? What times what is 10? 5 and 2. They have to add to be negative 3. Sign in the middle on the bigger. Minus 5 plus 2 is negative 3. And so then you know the answers. It's opposite. So plus 5 and minus 2. Plus 5 and minus 2. So that's step 2. So step 1 is right there. Step 2 is right there, solving for u. And now step 3, replace u and solve for the original letter. You always got to go back to the original. It's kind of like a sandwich. See how we have all this u stuff in the middle? See how we started with x, did a bunch of u stuff in the middle, then we go back to x at the end. How do we do that?
Well, we know that
U is 5. Okay, u is 5. So whatever u is, it's 5. So what is u? Well, u is always the middle.
X equals.
Right there. That's what u is. U is always the middle. So u is x to the minus 1. U is just an actor playing the role of the x to the minus 1. Is that good?
X to negative 1 over x?
We'll get there. But is everybody good to that step? Does that make sense? That's just like what we did on the other one. So you do the u work, you change to u because it's easier. Then you go back to the original at the end. And how do you go back to the original? It's always the middle. Not the number, not the negative 3, not the number, just the x stuff from the middle. Every time. Every time. Look back. Like right here. What was in, well, I didn't even show it. I just changed it without showing anything. All right, well, it was happening. I just wasn't even showing it. So, all right, so yeah, now how do we finish this thing? How do we need to get regular x. We're almost done. We need to get we don't want x to the negative 1. I mean, that's weird. What's that? We want regular. We want the answer for just plain, normal, everyday x, not x to the minus 1. Now, if you're thinking x to the minus 1 is 1 over x, it flips it, negative power, you're right. Good thinking. I'm glad you know that. I'm not going to, I mean, you could do it that way, but there's going to be an easier way because of some other ones, what they're going to do. Let me just suggest to you to do this. I'm not going to actually make it 1 over x, although that's true and you could do it that way. Here's what will be easier. I'm just going to say to myself, look, I need regular x, right? That's what I need, regular x. I don't want x to the negative 1. I want regular x. What does regular x mean? What power is on regular x? Yeah, positive 1, normal 1, right? Invisible 1, right? So that's what I really want. Let's be clear. We want x to the positive 1, don't we?
So you got it.
So what could I put here? What times negative 1 would make it positive 1? Negative 1, huh? Negative 1 times negative 1 would make it positive. I just got to do whatever it takes to make it into regular x, x to the positive 1. And whatever you do to one side, do to the other. So I do negative 1 power on both sides. Here, negative 1 times negative 1 makes positive 1, or regular x, which was my goal. What happens on the other side? What is 5 to the negative? What is now remember, what is anything to the negative power? Flips it. Doesn't put negative in the front. Negatives in the power zone flip things, remember? So real important to remember that in this section. 1/5. Positive. Doesn't make it negative in the front. Negatives in the power zone don't put negatives in the front. They flip things, don't they? So 1/5. Can you do the other side? Try the other side. U to the minus 2, you got to solve that one. Same kind of way. What is u?
2.
X to the minus 1. Right? It's always the middle. Use the middle. So what are you going to do to turn that into normal x? X to the positive 1, in other words. Normal x. What are you going to do? Going to raise both sides to the negative 1 power. Then negative 1 times negative 1 will be positive 1, normal x.
And normal 2.
Okay, now what does the negative 1 power do? Let's be crystal clear. Now fuzzy. For example, don't say, well, it multiplies. Nope, that's not what I've ever said. What does a negative in the power zone do? Flips it. Flips it. Right? Does it multiply that negative in the front? And that's the mistake everybody makes. Negatives in the power zone have nothing to do with negatives in the front. They are in two totally different worlds. Negative in the power zone flips things without any effect on whatever side's in the front, just stays there. He's not touching them. He lives in a different world. So it's negative 1/2, isn't it? That negative in the front is still there. He didn't go anywhere. But this negative flipped the 2. Remember, negatives in the power zone flip things. They don't touch negatives in the front, right? I try to say it loud and quiet and again, do whatever I can do. Is that good? Negative powers flip things. They do not multiply negatives in the front. Abraham.
x squared, negative x squared. You don't bring that down because you substituted.
Yeah, no, u is taking the rule of x to the minus 1. So u squared took the rule of that, because this is twice as big as x to the minus 1. So that's why it's u squared. So it was replaced right here by u squared, because it's twice as big. So it'd be like if I said, hey, Tom has $5, Joe has twice as much. How much Joe got? Well, $10. That's kind of like I'm doing. I said, hey, this guy in the middle, he's you. The guy in the front, he's twice as big. So what's he? U squared. It's an actor, right? Twice as much in the front. And so there we go. All right, let's try one of those. Look at. All right, let's try that one. So what do you let u be? Whatever is in the middle, huh? See how the one in the front is twice as big a power as the one in the middle? That'll always happen.
So
You
u
let
equals
u
W
be the
to
middle,
second.
and the one in the front is twice as much.
W to
So it's
second.
u squared.
Okay. So,
So the one in the middle is always u. You leave all the numbers there. We don't mess with the numbers. Everybody good with those steps? So step 1, u equals middle, and u squared is in the front, huh? We good? That's always step 1. U is always the mid-level. And the front, fourth power is twice as big as second power, so it's u squared. Is that good? And then solve for u. How are you going to solve for u there? Yeah, the factoring won't work. You need to do the quad on that one. This is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. On that. And that, yeah. So do that. So that'd be negative 20 plus or minus square root of b squared minus 4ac all over 2a. So that's 20 plus or minus the square root of 400 plus 8 over 2. 20 plus or minus 408 over 2. Wow, that one's getting messy.
it's not too bad.
Because then we got to simplify the square root of 408.
It's
On that one.
2 root 102.
Is that what it is?
Yep.
No. It's divided by 4, huh? Yeah. Yeah, and then we're going to need to, yeah. All right, I'm going to pause.